All right, our goal here is going to be to write the quotient of a complex number in standard form. Remember that when you hear the word quotient, you should be thinking division. When you hear complex number, you should be thinking, all right, this includes imaginary numbers. And when you hear standard form, you should be thinking a plus bi, where a is your real part and the bi is your imaginary part. All right, so let's take a look at a couple examples here. Well, before we do that, why can't we just leave the expression as it is? If we have 2 over 4 minus 5i, what is the problem there? And the idea goes back to you cannot have a radical in the denominator. So when you have 2 over 4 minus 5i, that is the same thing as 4 minus 5 times the square root of -1. Remember that I is the square root of -1, and we're never allowed to have this square root down in the denominator. So if I'm not allowed to have a radical in the denominator, I'm not allowed to have an I in the denominator because I's are square roots. All right, now an I squared would be different. If you had an I squared down here, remember that's -1, so that's not an issue. But my issue is when I just have an I here. When multiplying complex numbers, remember that you want to use a distributive property. If it's specifically a binomial times a binomial, you want to use the foiling idea, first, outer, inner, last. Is it possible to multiply the number 6 plus 3i, which is an imaginary number, by another number to produce a real number with no imaginary part? And the reason that I'm asking this question is because you're going to have problems where you have an I in the denominator, like maybe this would be 6 plus 3i. And, how am I going to get rid of this? And let's throw something on top here. Let's say we had 5 on top here for the numerator. What if I had 5 over the quantity 6 plus 3i? And I want to rewrite this quotient so that I don't have an I in the denominator because that's not allowed. Realize that I can't just multiply this thing by I. And so what you're going to want to do is you're going to want to take both, first off, you're going to want to take the top and the bottom and multiply by the same thing. Because when you multiply the top and the bottom by the same thing, you're really multiplying the top and the bottom by 1. So you're not changing the value of this expression, but you are changing what it looks like. And one thing that students are tempted to do in situations like this is they're tempted to multiply by I. They say like, oh, look, if I multiply by I over I is like multiplying by 1, so I'm not changing the value of this. But the problem is that when I distribute this I here to this quantity, I have 6i plus 3i squared. And the I squared is -1. So -1 times 3 would be -3. So I have 6i minus 3. But notice I just kind of moved where the I was. I still have this root of -1 in my denominator, so I didn't solve my problem. So I can't just multiply by I here. So is there a way to do it? And the answer is yes. If you multiply by what's called the conjugate, which would be 6 minus 3i, you will eliminate all the imaginary stuff from the denominator. So let's actually show that working out with the problem that I just had. So what did I just have for a problem? I had 5 over 6 plus 3i. So let me rewrite that. 5 plus 6 plus 3i. All right, so I'm going to multiply the top and the bottom by the same thing. I'm going to multiply the top and the bottom by the conjugate. And I'm using this word conjugate, but I don't know that I've fully explained what exactly the conjugate is. So the complex conjugate of a plus bi, so any number written in that standard form, is a minus bi. So notice that all you have to do is change that sign in the middle. So if you had the number 8 plus 2i, the conjugate would be 8 minus 2i. If you have 7 minus 13i, the complex conjugate would be 7 plus 13i. So for anything that's a plus bi, it's a minus bi. Now, let's finish up that problem that I was started over here. So I'm multiplying both the top and the bottom by the same thing. So I want to be very clear here. I'm multiplying by 1, not changing what this value is, but changing what it looks like. Let's distribute this 5. 5 times 6 would be 30. 5 times negative 3i would be minus 15i. So there's my numerator. And now I got to FOIL this. 6 times 6 would be 36. So I took care of this part of foiling. Now I got to distribute the 6 to the negative 3i. 6 times negative 3i would be minus 18i. Positive 3i times positive 6. I got to distribute this 3i now. This is the I part of FOIL. 3i times 6 would be plus 18i. And 3i times negative 3i would be minus 9i squared. Now, when you get used to this, you won't even need to, maybe you can just skip writing all this right here, because notice this all cancels out. Negative 18i and positive 18i are opposites. That's 0. And that's always going to be the case whenever you multiply by the conjugate. That's the whole point here. When you change this sign, the outer and the inner part of FOIL, regardless of what numbers are here, are always going to cancel out and add to 0. So you're really just going to end with the F and the L part of FOIL. Your first terms are 36. And let's take care of this I squared here. I squared is negative 1. So this would be 36 minus 9 times negative 1. And we still have that 30 minus 15i on top. 9 times negative 1 would be negative 9 minus negative 9. That's the same as 36 plus 9. And 36 plus 9 would be 45. So we have 30 minus 15i over 45. And notice that we have no I stuff in our denominator here. So we have rationalized our denominator, and we're good to go. One other thing here, notice that this can be simplified. I can actually pull out a 15 here. So this would be 2 minus I. And I have that over 45. 15 over 45 reduces down to a third. So I can view this as 2 minus I over 3. And to get this in our standard form of our complex number, we could write this as 2/3 minus 1/3 I.